and welcome to my episode of Women Who Code podcast, where I'm going to talk about the challenge many projects face and real life example of solving it. The title of this talk is Leading Technical Transformation at Projects While Releasing New Features Regularly. And it's very long title, but I will bring more details so it's gonna get clearer. But before we dive into the topic, I would like to introduce myself. My name is Anastasiya Meishutovich, and I have more than 10 years of experience in software engineering. I started as a backend engineer and currently working as senior engineer and technical lead of reconciliation team in Duco. Duco is a fast-growing company. We help our clients with managing data on scale and solving the problem of consolidation, standardization, and reconciliation any type of data. And increasing number of clients and volumes of data users submit daily, complexity of requests raise the need of improving performance by making fundamental changes in architecture of our SaaS platform. In this case study, I will show you the approach my team and me have chosen to mitigate the risk of adopting new technology and making crucial changes, but also we'll talk about rolling out in controlled manner. So let me bring a bit more context here. At some point, our users started noticing some performance degradation. For example, when they work with particularly large reconciliation results. After some immediate performance enhancements, like of queries and of our MySQL configuration, such as changing order in joins of our queries, introducing new indexes, introducing maybe nested queries, maybe using temporary tables, etc. We realize that it's not enough, and the trend of growing volume of data and diversity and complexity of filter conditions and also growing number of active users, all this is pushing us to a completely different architecture. So the main challenge here was the access and filtering data on scale. Because our clients wanted to work with the reconciliation results with almost like with zero latency. And this is how idea of creating a custom cache layer on the base of ClickHouse database was born. So primary and the main source of truth was still MySQL, our main database. But in ClickHouse, as only when we need it, we copy data from MySQL, from our primary source, and build on top of that temporary reconciliation result view in ClickHouse. So ClickHouse view were by default optimized for heavy reads and diverse filtering conditions. But also nature of ClickHouse database, like column-based database, impressed us with the performance and performance of read queries specifically, but also simplicity to work and integrate with. For example, ClickHouse understands SQL, and overall we found it very, very similar to how we work with MySQL. Also, we had multiple spikes and proof of concept, which demonstrated dramatic improvements and potential. So engineering team decided to move processing of reconciliation result request to the new service on top of ClickHouse. This was a really large technical transformation project in the core of our application for improving performance and scalability and yield benefits from adopting new technology. But despite of the scope and risks, it was so crucial. So we can't really postpone it. And in the meantime, we were thinking that we can't really allow it blocking new features from other teams. So we, like our engineering team, had to guarantee zero regression and no disruption for users. And users ideally should see in the result of this project, they should see only better performance, and that's it. No functional changes. And also, again, we were keeping in mind that there are other teams and changing code. They changing code actively, and they're releasing new features actively as well. So we don't want to block them. So what did we do? First, we started with detailed technical documentation, and the large scope. We decided to split it into deliverable chunks to avoid waterfall approach. The very first milestone represented MVP, minimum valuable product. In our case, it was showing static reconciliation results for just one type of processes. After getting reconciliation job completed. At that stage, we had to build only data model for ClickHouse database, synchronize MySQL and ClickHouse to get data from one database to another, and implement API controllers and to allow those API to serve front end. Every following delivered chunk of logic enabled a new function to user. So new process type support, or editing data, or filtering data, or sorting data, a recovery from issues, cleanup, etc., etc. It was like very small scope for each milestone. But also, apart from functional aspects, we define non-functional requirements. We agreed on testing. For example, we include performance, functional, and resilient suits. All of them were like separated in separate suits because they have separate targets, like different targets. We discussed rollout plan, and very importantly, we had to define metrics because we had to answer the question, how do we know that something is working? How do we know that something is performing well? So for beginning, it was just success failure ratio, read write ratio, time of round trip of request, and cache rebuild time. Also, some ClickHouse internal metrics. Except for planning and estimation purposes, we used the technical document as a reference for other teams. For example, team infrastructure, we needed testing environment with the preloaded data and support with going live. And we had to communicate with them and explain what do we need and when and what the project is about. Also, we had to communicate with other teams as well, because their services, pipelines, plans might be affected. As you can see, all our decisions had a goal of minimizing risk and how to be confident, how to build, how to develop in the way that we're confident with our releases. That's why we set a goal of getting feedback and metrics as early as possible and escape long living feature branches and big bands when we merge them. So small iteration, integrating changes early and frequently became essential. The very first thing to do was introducing a feature switch. It allowed us to merge code and unit integration tests into the main branch, but hide it from users until we're ready to the feature to be enabled. But the problem of the code not being used remained because feature switches were off, and even on QA, and specifically on production environment. It wasn't ready. It wasn't ready to substitute all functionalities, so it is understandable. It was less than ideal for us because no interaction with logic happens, even if it's just QA environment. So we're getting zero feedback, zero natural validation, zero bugs, and other teams also could break our code without even noticing it. So it was dangerous to leave it like that. And it was all because it wasn't actively used. So immediate solution was writing some end-to-end test to prevent code to be broken by other teams. And then we integrated those end-to-end tests to be run as a part of pipeline with the two modes, feature switch is on and feature switch is off. So we were testing two flows, when regression testing and our feature testing as well. But the main challenge was in proving that the changes we deliver, A, don't bring regression in functionality, and B, performance is improved. So proving is the key word here. Because the testing tools were used at that point, they had quite some disadvantages. For example, unit and integration tests, they cover only specific parts of functionality. And end-to-end tests and performance Gatling tests, they heavily depend on data characteristics and volumes in database, but also types of requests and their frequency. So there were so many elements of equation, which, yeah, you can never be sure that you identify them correctly. They are imperfect by nature because the scenario reflects developers' understanding of the way how clients using the platform. With growing number of diverse clients, it's impossible to guarantee. And also, no QA database could be as large as production database, not only because it's extremely expensive to support such huge database, but also because different clients on our production service, they have slightly different configuration database. So which client would you pick as a target, as example to test against? That was a question. So in summary, summarizing everything, to prove we achieved the goal, we needed production-like data and production-like volumes and real-life scenarios at the same time. And that's the key moment of this podcast. Traffic mirroring solved this problem for us. And that helped us to make this project successful. This is a concept. On production environment, we deploy new service. And we set up ClickHouse database. We expose new API endpoints side by side with existing service and its API. But nothing changes for user. They still interact with the main API, and it delegates requests to the main service. But every request to the main service is now mirrored to the new service API, which means the same user request is processed twice, by main service and by new service. But again, user still gets response from the main service, from the primary database. So it's zero risk because nothing changes from user perspective. But this way, our new service works with real data and real requests. And we log metrics and we check correctness of each response by comparing both responses are the same. So we're gathering statistics in the background. A very important moment here that we had to make sure that traffic mirroring won't affect system functionality. We had to prevent errors and slow responses. And this is how we do it. Traffic mirroring had its own feature switch to separate some necessary code adjustments from the feature implementation. In traffic mirroring mode, there were no modifications of the main database. That's very important. We didn't want any changes because of our testing. So our tests were checking that on unit testing level. In case of any errors in traffic mirroring logic, we caught it, we logged it, but we prevent any further propagation. So we set a timeout for traffic mirroring request, taking in case of if some request taking longer time to complete. Later, we added possibility to destroy and rebuild the cache layer if needed. I would like to say a few more words about how we were comparing old and new request processing because it's the key. Old and new services old and new services, they log request ID, timing, hash of response result, because logging all items from response was just inappropriate decision, and also some metadata of a run. We decided not to implement any real-time comparison tool because we were cautious of possible latency it might bring. Just imagine, it takes time to compare responses, but also it makes both requests for main service and for new service depend on each other. And we had to wait for slowest request to complete. And it brings some risk because what if slowest gonna be too slow? Instead, we logged metrics of both requests independently, and we could compare responses and their metrics by finding the same request ID in logged message, because two responses, they should have the same request ID, and then they're gonna be comparable. Then we parse log messages with Elasticsearch, so that those logs were available in Kibana, Grafana, and we were able to visualize and build dashboards and use those metrics for monitoring and comparing automatically and observe trends. So also we established upper limit of request processing time for the new service and created an alert based on that in Grafana. Also, before enabling traffic mirroring on production, just for one process, we tested Grafana dashboards for monitoring and alerts on QA environments. Also, we didn't enable traffic mirroring for all processes for all clients simultaneously. That's very important. We were enabling one process per time, and when we built it, when we were sure that actually it's safe to enable for whole client, we were doing that. So it's very incremental changes. because we had the traffic mirroring feature switch had very granular scope for that. But it's fair thing to say not everything went smoothly. So, for example, as you saw, there were so many small moves, small steps, and they required a lot of communication and approvals because we were, as I said before, we were touching core logic of our application of our system, and we had to be transparent and to other teams and keep their awareness of what's happening. And we probably underestimated a little bit the organizational overhead, and it slowed down the process a little bit. So we learned about planning ahead and communicate even earlier than we used to. That's a lesson number one. Lesson number two, that sometimes we had to apply a lot of adjustments in the code to prevent database modification or to be careful with the effect of traffic mirroring. For example, we worried about performance, null pointer errors, and such, etc., etc. But hiding that behind feature switch and removing later, we decided that it's a right way for us. So we were trying very hard to bubble it under feature switch. And the main lesson is specifically for me, it's about perfectionism because of the specifics of our code base. We couldn't mirror every single request because we have some specific filtering requests and very special types. So it would be very expensive to support everything. So we decided to skip those because we decided that we don't need the perfect tool to cover all possible requests. All what we need is getting information about correctness and performance of majority requests, to see trends, to find maybe some special use cases which we didn't cover and log them. And that was sufficient to make go no go decision. So don't let perfection to be enemy of your team. So while we were developing next stage, every time we were gathering statistics for a week or two from traffic mirroring feature, and then we repeat cycle. We build, we release, we monitor in control, low risk way, and then again we build next milestone, we release, and then we see how things performing. And eventually we guaranteed personalized statistics from production environment, and we were able to prove readiness of the service to be enabled fully. And also we had this opportunity to have statistics for client before enabling feature fully. So we could enable traffic mirroring first, make sure that the client case is ready for custom cache, and then enable custom cache for them. So it was like very personalized proving tool to lower down the risk. In conclusion, I would like to mention that many of our clients already benefit from using the new cache service and ClickHouse database. We plan to expand the functionality even further, and now we have a reliable process to achieve that. So this is how granular feature switch and traffic mirroring help us with integrating our changes early, build new functionality while gathering important metrics, including correctness and performance. And finally, we managed to take under control the risk of such ambitious project. So thank you so much for listening. It really means the world to me. And if you have any questions, please find me in social networks. Thank you.